Name is Olenjolai TAYAI from the beautiful and fantastic country in East Africa called the Tanzania, and this is our national flag. I would like to welcome you into our fantastic official YouTube channel that's called the Online Diploma Poly Institute of Tanzania. So this is the official online online schools or online institutions, which is called the Online Diploma Polytechnic Institute of Tanzania. So in square brackets is Olenjolai. So in these official YouTube channels, we are teaching students all about engineering mathematics, and science mathematics, means or scientific mathematics that used for scientific. And basically our main focus here, we are teaching material which are basic engineering mathematics and basic scientific mathematics. We have another YouTube channel that's called the Online Undergraduate Polytechnic Institute of Tanzania, Olenjolai, where we teach higher engineering mathematics and higher scientific mathematics. So stay tuned, and I would like just to ask you that in order for you, because this is a serious YouTube channel, I would like also to teach serious students, because we are very serious on this program, and also we believe that even the students will be taking these programs will be serious, or if you are not serious, they will be ready to be from seriousness into the seriousness. So today I will be teaching a module called Geometric and Vector, and the reference institutions is the National Institute of Technology, and the year of study is NTA level 5 according to the NACTE. Okay, it's first year programs, but can be used by any students. This material might be used in any material in any continents, in any country, in any college, in any institutions, in any university, because mathematics still the same. Just having a reference curriculums is just to have a focus on what you have to cover, just like an example. But I'll be teaching you different concepts about the vector. The chapter or the topic that will be teaching you is called the vector, and this is lecture 2. I've already taught you lecture 1. Make sure that you go through lecture 1 before you come to this lecture 2. In this lecture 2, I'll be teaching about representations of vectors and terminologies of vectors, which is very fantastic and fundamental concept for you to understand and master the topic of vector. So I would like just to, in case also that you want to offer your Thanksgiving, you may use this number. This is Thanksgiving offering from your heart, freewheeling Thanksgiving, and you may use that. This is +25, so not that number, +255 7597 45331. So I would like also to insist you to make sure to subscribe. You sign in on your YouTube, on the YouTube platforms, and then you have to subscribe in order to get notification for every lecture or every video that we are going to upload, because always we'll be adding videos onto this official YouTube channel, and those videos will be there for you to learn and take them anywhere at any time. Also make sure to share this content material to millions or to the thousands of other students who are in ordinary diploma level right now, or even in the future, because this contains for the present and the future generation. So if you do all of that, in case also, because you know that you might be asking yourself, this is the digital programs. Yes, these digital programs we are using are high definitions digital equipments to record a live lecture or a live session or a live period, okay, of engineering or basic engineering mathematics or basic scientific mathematics. So even yourself, you can use the digital tools to ask your questions and interact with me, because you know, teaching you without being asked questions, my class will be incomplete. So I want you to make our classes to be complete by asking questions in the comment section. So make sure that you also read the descriptions of this video, so you can know even some other official YouTube channels and other information concerning about the lecture or concerning about the topic that we are teaching you today. So I think that now you are ready in good positions. Take all the required materials, your scientific calculator, your exercise book, your pens, your pencil, all the essential materials, and then concentrate and pay and have a focus on this lecture. So today, as I say that I'll be teaching you representations of vectors and terminology, but before I take you into the lecture 2, I would like just to do the quick review of lecture 1 where I left also a kind of homework. If I didn't leave the homework is just sometimes review the material. So in lecture 1, I introduced you, I did a simple introduction of the channel, okay, introductions of the channel, introductions of this channel. That's what I did in lecture 1. But also in lecture 1, I did introductions of 40 of reference books and materials, useful to learn this module. Okay, again, I mentioned the contents of vector, right? The contents of vector. We call contents or concept different concepts of vectors, and we covered the one which was introduction of 40, introduction of vector. So I told you introductions of vector, and introductions of vector, we learned the definition of 40, what the meanings of vector, right? And also I told you about 30. The last concept is notation of 40 of vector. Okay, so hopefully I didn't leave the homework, but don't think that the situation is. So I'll be leaving many homeworks in every lecture from now onwards. Okay, notations of 40 of vector. And then I taught you different notations that we use in engineering and also use in science and even in pure mathematics. So if that's the case, make sure you go through to understand what the meanings of vector. We say that vector is a quantity, the physical quantity, which are both marking to the dotted direction. And in mathematics, sometimes it's not like maybe in physics that the quantity should have marking to the and unit. In mathematics, can have a number. That's all. Okay. So hence the notations, you have different ways of notations, and I might even use some of them. So now let us go into the lecture 2, and I would like to teach you representation. Let us go to the representations of vectors and terminologies. Okay, so let us start with representations of a vector. Okay, representation of a vector. So representation, so say with me, representation of a vector, So representation of a vector. So we say that a vector can be represented, okay? Vector can be represented in 2 ways, right? In a plane or in direction. In the plane or direction. So this is the first way, this is the second way of representing a vector. So this is the first way, and this is the second way, which I'll be teaching you in this lecture. In directions of 40, in direction of unity vector. Unity vectors, right? So that's how we present. So the result of vector depends on the dimensions of the vector. Again, say that the representation of a vector depends on the dimension. So we have something called dimension. I'll teach you soon. Dimension of 40 of a vector. Dimension of a vector, right? So before we go through, it means that even we learn more about the different presentation of vector, I would like to teach you the meanings of dimension of a vector. So say dimension of a vector. Dimension of a vector. If you go for undergraduate studies, we learn the dimension of partial differential equation. So dimension of 40 of a vector. So you say that in the fundamental question that comes in your mind, what is dimension? So what is dimension of a vector? That's the first question. What is the dimension of a vector? Dimension of a vector. Okay, what is the dimension of a vector? The dimension of a vector, we say that is the number. Simply, in mathematics, we say that is the number of axes. The number of axes is the number of axes used to representing a vector. The number of axes used to representing a vector. At the meaning of 40 of the dimension of a vector. So you say that in basically engineering and scientific math, there are two types. Well, there are two types of 40. There are two types of dimension. The first one, we have two-dimension vector. We have two-dimension vector. Two-dimension, so we call it 2D. 2D vector. So you have two-dimension vector, right? So the question is, what is it? So you say the two-dimensional vector, 2D vector, is a dimensional vector that consists of only two components, axes. The two-dimension vector is a dimension of, or is a dimension that consists in the dimension of a vector that consists only two components. That consists only two components. Okay? And you say basically they are X and the Y axis. So what does it mean? For example, you are familiar with this dimension of vector. For example, you can have vector A presents at a point, then you have X, Y. Or vector B, we have 2, 3. Or you can have vector P, and then you find that is 0. After covering the concepts of the two-dimensional vector, then we come to the second type, which is called the three-dimensional vector. The three-dimensional vector is a vector that consists of only three components. So basically, these components in mathematics, in basic mathematics, we call grow, it means that even we learn more about the presentation vector. I would like to teach you the meanings of dimension of a vector. So say dimension of a vector. Dimension of a vector. If you go for undergraduate studies, we learn the dimension of partial differential equation. So dimension of 40 of a vector. So you say that in the fundamental question that comes in your mind, what is dimension? So what is dimension of a vector? That's the first question. What is the dimension of a vector? Dimension of a vector. Okay, what is the dimension of a vector? The dimension of a vector, we say that is the number. Simply, in mathematics, say that is the number of axes. The number of axes is the number of axes used to representing a vector. The number of axes used to representing a vector. At the meaning of 40 of the dimension of a vector. So you say that in basically engineering and scientific maths, there are two types. Because there are two types of 40. There are two types of dimension. The first one, we have two-dimension vector. We have two-dimension vector. Two-dimension, so we call it 2D. 2D vector. So you have two-dimension vector, right? So the question is, what is it? So you say the two-dimensional vector, 2D vector, is a dimensional vector that consists of only two components, axes. The two-dimension vector is a dimension of, or is a dimension that consists in the dimension of a vector that consists only two components. That consists only two components. Okay? And you say basically they are x and the y axis. So what does it mean? For example, you are familiar with this dimension of vector. For example, you can have vector A presents at a point, then you have x comma y. Or vector B, we have 2, 3. Or you can have vector P, and then you find that is 0. After covering the concepts of the two-dimensional vector, then we come to the second type, which is called the three-dimensional vector. The three-dimensional vector is a vector that consists of only three components. So basically these components in mathematics, in basic mathematics, we call them x, y, and z. Okay, so I gave you some few examples. Vector P, which is representing three components, X, Y, and Z. And then Q, which is representing 3, 4, 6. And then you have again a vector which is consisting alphabets. It means that A, B, C, D, A, B, C. And then you have another vector B, which is -2, 0, 3. Again, another concept after, now you know the two main types of dimensions, or the two dimensions of the vector, two-dimensional and three-dimensional. That is good. So after covering that concept, I want to teach you how to represent. Let us start with how we can represent the two-dimensional vector. The two-dimensional vector can be represented by using either a plane or a directions of the two unity vectors that I will teach you. Don't worry about that. Then we learn these representations in all level, but possibly they are not insisted. That's why I'm insisting, because we need them as engineers, we need them as scientists. Okay, so then representations of the two-dimensional vector in two-dimensional plane, because we start with a plane, then I will teach you how you can represent the two-dimensional vector in directions of the two unity vectors. So the two vector is presented in a plane as a set of ordered pairs. Set of ordered pairs, say set of ordered pairs. So we present this as a set of 40 of ordered pairs, x, y. X represents horizontal axis and y represents the horizontal vertical axis, so we call it horizontal components and vertical components. And this is very important even in science, for example in mechanics, that in resolving the forces, or resolving the electric field strengths in electrical engineering, or resolving the magnetic field strengths, you see, or resolving the gravitational potential energy. Very important. So example that we have a representing vector A, which is 2, 4 in a plane, meaning that this representation, this is the x-axis, y-axis, and this is vector A, which is starting from origins. This we call the positional vector. I will teach you in terminologies. And then we have against another vector, which is vector B, and we present it such as -x, -y, and then we present a positional vector from O to B. So you can have some other vectors in there. This is, we call it in trigonometric, first quadrant, second quadrant, third quadrant, fourth quadrant. So you can have even some other vectors, maybe even displacement vector. Let's say you can have a displacement vector, which is C, which is vector C to D, or CD. So suppose that is moving from a certain point and then in this direction. So suppose that the point C is equal to -x1, -y1, while this one is 40, -x2, -y2. So this is, we call it displacement vector. So I will teach you in part of terminologies. This is the way that we use our interpretations like that. So this is how we present a two-dimensional vector in a plane or in 2D plane. In case you have any question, don't hesitate yourself to ask in the comment section. Okay, so after teaching you that how we can use the two-dimensional plane to present a vector, then now I would like just to show you some few example presentations of the two-dimensional vector in, in a plane or in directions of I and J. So I believe that you've understood that we can present a two-dimensional vector in a plane. So let me teach you how to present a two-dimensional vector. So we come to number 2, presentation of what? Of two-dimensional vector. Two-dimensional vector in a direction of what? Of I and J. I and J. I and J. So you say that I and J are two unity vectors that are used to represent the two components of a vector. I and J are the two unity vector. I'll teach you about the meanings of unity vector if you forgot, but we still have the same meaning. We have a unity vector in vector. Unity vectors that can be used to represent what? A two-dimensional vector. Okay? Two-dimensional vector. So for example, two-dimensional vector. So what are the values of this? So you say that I, which sometimes that we have this waved line, is have a value of 1, 0. And in terms of x, because we represent the x components, you can say that this is x, 0. And then j as a unity vector is value 0, 1. And this in terms of the axis, we use to represent the y component or the vertical component of the plane. So for instance, for example, these are the simple examples, we don't count these as examples. For example, represent, we have vector A, let's say it is x, y, and then we have vector B, it's 1, 6. We have vector C, it's what? -2, -4. And possibly we have vector D, which is possibly -2, -5 in direction of 40 of I and J. Because I told you at the points. So how we present them? So we say that for instance, vector A, which is given as x, y, this will be written as xi plus yj, can have a waved line. And then we have vector B. Vector B is written as 1, 6. And this one we just multiply with what? With I. And then multiply this one with j. So then we have vector C. This is -2, -4. And then this is -2i minus 4j. Again, we have another vector, which is vector D, -2, -5. This is equal to -2i, then -5j. So these are the representations of vector in directions of I and j. Okay? So then now you are familiar. So we'll be using these two representations interchangeably. So you have to be familiar on it. In case you have any question about presentation of two-dimensional vector in a plane, or the presentation of the two-dimensional vector in direction of unity vectors I and j, please ask me in the comment section. So that's all about presentations of the vector, two-dimensional vector in what? In directions of I and j. So let us go now to the next concept. Let me teach you presentation of three-dimensional vector, in a three-dimensional plane. In three-dimensional plane. So you can represent a three-dimensional vector in a three-dimensional plane. How? So you say that the three, or we call space plane or space vector. Okay, the three-dimensional vector is presented in a plane at a set of three ordered components. The three-dimensional vector, three-dimensional, or we call it, some of the books call it space vector, can be represented in 3D plane as what? At the set of what? At the set of 40. At the set of ordered components. At the set of ordered components, which is x, y, z. So listen carefully. I would like to reveal the secret of three-dimensional vector. It's a little bit confusing, so listen carefully because I would like to take you into the next level of what you used to know. How do you get it? Remember that all the three axes of three-dimensional plane are perpendicular to each other. Perpendicular to each other. These are perpendicular to each other. Okay? So let us start from the primary concept. Let us start with two dimension first. I'll be sketching the two-dimensional plane. And then we having the third dimensional plane. So suppose that this is the x-axis. Right? So here we have y-axis, here we have x-axis, like this. This is origin. Okay? This is origin. And then this we call the y-axis. What I told you a few minutes ago, this we call the x-axis. And this is positive x-axis. And this is negative x-axis. This is positive x-axis. And this is negative x-axis. The positive x-axis is perpendicular to the positive y-axis. The positive y-axis is perpendicular to the negative x-axis. The negative x-axis is perpendicular to the negative y-axis. Then the positive x-axis is perpendicular to the negative y-axis. So these two axes are perpendicular in both sides, on positive side and also on negative side. Then let us think about where we're going to introduce the third. Okay? The third plane will be perpendicular also to all the two axes. Okay? So this is what we call the third plane. So because this blackboard is two-dimensional plane, it's difficult to present the third axis, which is that axis, the way it is. It means easy because the blackboard is two-dimensional. So this is positive. So this is positive what? So this is positive y-axis. So the negative, no, excuse me, this is positive z-axis. So positive z-axis. So the negative z-axis will be inside the blackboard. So then this is also, this one is perpendicular to the positive y-axis. This one perpendicular to the negative x-axis, perpendicular to the negative y-axis, perpendicular to positive x-axis. So because we have this challenge, we use the way that mathematicians agree themselves, we agree ourselves to represent the 3D, the three-dimensional plane on the two-dimensional plane, which is a little bit challenging because if you don't understand, you can disagree that these three axes are not perpendicular to each other. So you say that representation of what? Of 3D plane or not on 2D plane. 2D plane. So let me show you how we do represent. So we can have the two axes as usual, the two common axes, the vertical, and we used to call it y, but if it is three-dimensional, we might not call y. We might call it x, we might call it z for three-dimensional. But let us start with the notation that this is y-axis, this is y-axis, and this is x-axis. You agree that these two axes are perpendicular. So then the z-axis now, we can represent it downward in this way. They are not possibly 180, or they are not, let's say we call it 120 separated. They are not, the angle between them is not 180, but is perpendicular. But the way we just represent it. So also this is positive VT, positive ZE axis. Positive ZE axis. So this is positive Y axis, positive X axis. So you know that in case you want to show the negative X axis, and this one we can show the negative Z axis, and this one we can show the negative Y axis. So this is the way that you present the what is three-dimensional. But remember that the X, Y, Z, they can be represented interchangeably. The Y axis, this can be called X axis, can be called also Z axis. This can be called the X axis or Y axis. This can be called the Y axis or Z axis. Okay, so bear that and keep it in your mind, because you might need that concept in solving problems. So if that's the case now, for instance, we have, we like just to present some of the components in this. However, that we have a question for this case. We say, for example, I still just a slightly example, just to understand the concept. We present, for example, represent the vector A, which is x, y, z. Let's say vector B, 1, 1, 1. And then say vector C, 2, negative 4, or negative 1, possibly, 2. So, for this case, we can sketch our plane like this. I have a question for this. I have a homework on this part, so listen carefully. So suppose that this is our y-axis. Sometimes also we represent the axis in this way. This is z-axis, and then the other axis we may represent in this way. Remember that all these three axes are perpendicular to each other. So this is the y-axis. This is engineering mathematics and higher scientific mathematics. So stay tuned, and I would like just to ask you that in order for you, because this is a serious YouTube channel, I would like also to teach serious students, because we are very serious on this program, and also we believe that even the students will be taking these programs will be serious, or if you are not serious, they will be ready to be transformed from unseriousness into the seriousness. So today. as we say that representations of the, I've taught you, just to do a quick review of what I've taught you. Presentations of the 3D planes on the 3 and the 2 planes is just like this one. So we say that this is what positive y-axis, x-axis, z-axis, and I told you that this is the perpendicular axis, right? This is the perpendicular axis. And then this is negative y-axis, negative x-axis, negative z-axis. So for instance, a simple example represents the vector A, x, y, z, and the vector B, 1, 1, and vector C, 2, negative 1, 2 in a plane. So represent this vector, you find that, well, so this is the axis, so it is point C, this is point B, this is point X. Remember that the z-axis, because the way that we draw, this is y-axis, the x-axis, the z-axis, this is perpendicular axis, which is z-axis. So both, or not both, all the 3 vectors, vector A, vector B, vector OB, vector OA, and vector OC are space vector. So the point is lying here. So for instance, this one, which is x, y, find it somewhere here, or the point might be here, that means of space vector, or the point might be here, or the point might be here. So a point might be here. So that means of the space vector, because the blackboard is two-dimensional, y-axis, x-axis, right? So if you are familiar on that, now let me take you to representations of 40 of two-dimensional vector, three-dimensional vector in 3 or in unity in direction vector I, J, and what? And K. So how can it present a 3D vector in direction vector of I, J, and K? Well, so for instance, you'll be given vector A, which is x, y, z. So its directional vector will be vector OA. It will be x, I plus y, j plus z, k. Then for instance, that will be given vector B for that case, which is 1, 1. Then this one will be positional vector OB. This will be what? I plus j plus k. Again, we have another point which is C, which is 2, negative 1, 2, negative 1, 2. So then we say that OC, this is equal to what? Is equal to 2i plus minus j minus 2k. Right? So those are the way that we present positional vector in directions of I, J, and K. So I believe you've understood everything. It is a simple stuff. In case that you have trouble in any point, let me know in the comment section. Okay? Then we have an example. Part of it is an example, and part of it is a homework. So consider this as example 1. Locate point Q, point P, which is 2, 4, 5, P, and then we have point Q, which is negative 2, negative 3, 4, and you have point R, is negative 2, negative 3, 4, and S. Point S or vector S is negative 2, 4, 3. It is three-dimensional. So locate it in three-dimensional. In three-dimensional plane. So I will teach you how we can locate this one. This will be your homework. You can locate, try to locate, and also this one will be your homework. This point will be your homework. So I will teach you how to locate this point and this point, right? And then you enjoy the beauty of 40 engineering, basic engineering mathematics, and also basic scientific mathematics. So we say solution. So solution, we say that, well, we have representation of a vector here, or we have one axis of the vector at point, then we have another axis of the vector at this point. So suppose that this is y-axis, because you are familiar. This is z-axis, positive z-axis, and then so you have x-axis, perpendicular x-axis. So this is perpendicular x-axis. Okay, so all the axes are perpendicular to each other. Then we can have, let's say, this is 1, 2, 3, 4. So 1, 2, 3, 4. And then for the y-axis we need 5 units. 1, 2, 3. We should have the equidistance. So 1, 2, 3, 4, 5. So, and then for the z-axis, similarly, however, that this is perpendicular, it's the space axis. This is 1, 2, 3, etc. So it's the space. So you can locate now point P. So point P, the x component is what is 2. So this is the x component. The y component is what is 5. So simply say that our notations here will be, you can locate our vector at this point. This is point P, where we have, but remember that the z-axis is a space vector. So it is 1, so possibly somewhere here. So this point is a space vector. So suppose the point where I place my chalk is a point where we can represent this space vector, because this is point, this is 4, excuse me. This is, the y component is 4 for point P. Thank you, God. So the y component is 4. So this is 2, 4, 5. So if you want to show this is space vector, this is z-axis, in actual presentation, then you might find that this is space vector is somewhere here. Right? So that's the point P. And then I told you that I will teach you how to present the point S, negative 2, and then 4, 3. So negative 2 will be somewhere else here in x-axis. Okay? So this is will be the x-axis. So you can draw the dotted lines to show that this is x-axis in the two-dimensional plane. So possibly this is the point where we have negative 2, and for the positive 4. So for the value of y, still the same value, which is positive 4. Positive 4 and 3 is positive 3. So it is a space-shorty vector. So here we write the print word S. This is negative 2, 4, 3. So remember that this is original. So it's a space vector. So we can draw and we can have even a space vector, which is we call it positional space vector. I will teach you in the next concept. So this is called the space vector, like this. So we call this positional vector. And this is really positional vector. So this is positional vector or B. I'll teach you all the meanings of positional vector. And this is positional vector or S. So in directional vector, the vector OP, we can write that it is 2i plus 4j plus 5k, right? And then the positional vector OS, this we write as what? As negative 2i plus what? Plus 4j plus what? Plus 3k. Right? So that's all about representation of a vector in a plane and also in single dimension. So let me spend some few minutes before I end this lecture to introduce you the next concept that terminologies used in vector. Terminologies that we have to know whenever that you want to learn about vector. So terminologies. So now I would like to take you into the next concept that we call terminologies. Say terminologies. So, I used to call it the language of vector. Terminologies. Terminologies of what? Of vector. Or used in vectors. That's the meaning. So you have many terminologies, almost 7 to 8 terminologies, and even some of the terminologies we encounter them later, as long as we study this basic engineering module or basic scientific module. So some of the terminologies, the first one we call the positional vector. Positional vector. Say positional vector. Positional or position. Positional. Call it position. Positional vector. Let me check. Let me counter check. Quality position vector. So position vector. So the question, the fundamental question you have to ask yourself, what is position vector? What do you mean? What is position vector? Ask your neighbor, ask yourself, pause the video and ask yourself, what is position vector? What do mathematicians mean when they say position vector? Good. So I believe that you have formed some of the answers. Let me now give you the meanings of position vector. So position vector, we say that is a vector whose initial point, initial or starting point, initial point is what? Origin. And final point is a certain point, another point. So that's the meanings of a position vector. Position vector is a vector whose initial point is what? Origin. Remember that a vector has both magnitude and the direction. So it means that a vector should have the initial point and also the final point. The initial point in mathematics we call it tail, and the final points we call it head. Right? So in how do you present? So representation, so we represent positioning vectors. I have already explained it slightly. Present position vector. Present position vector by using origin, which is called as initial point have. For instance, we have positional vector OA, and this one can have, let's say, I minus j. Right? Can have a three-dimensional positional vector which is OP. And this one, we say that might have a point 3, 4, 5. Can have a positional vector OB. So B, it is 3j plus 4. Okay? Etc. etc. So in two-dimensional, you find that positional vector, we just present it and we draw it from what? From the origin. So this is the origin. So for instance, if you have a line or a vector from origin to point A, so in this direction, then this vector is going to OA, like this. So this point A might be a certain point equal to x, y. So all of these are positional vectors. So I've already taught you how to present position vector in a plane. So position vector is very important whether in concepts of three-dimension or in concepts of of two-dimension. Okay? So in case you have any question about position vector, let me know in the comment section. Okay? Again, another concept that we have a terminology. The second terminology is called magnitude. Say magnitude. Magnitude or modulus. Magnitude or modulus of a vector. So what the means of a magnitude or modulus of a vector? So magnitude is a size of the vector that so you say that magnitude of a vector is the length or size of the vector from or measured from initial point to the final point. The final point. That is. So we present the vector, or present what magnitude of a vector, present magnitude of what? Of a vector by using this symbol. So that the symbol that we are using presenting magnitude of a vector. So we say that the magnitude, for instance, the magnitude of two-dimensional vector, this is given as magnitude, for example, of positional vector OA is equal to the square root of x squared y squared. Then again you say that the magnitude of three-dimensional vector, this is given as square root of x components square plus y components square plus z component square. That's how we find magnitude of 40 of a vector. Okay, magnitude of a vector. So that's the second terminology of a vector, magnitude of a vector. I will give you summarized examples of how we can find magnitude of a vector. So in a plane, similarly we say that, as we say, that maybe in an X-ray plane, you can have a sketch like this. So just a sketch. You have, let's say, two-dimensional plane like this. And then you have horizontal axis like this. And then suppose that we have point A. This is, suppose this positional vector. And then magnitude of vector, we just have a notation. It's a length or distance from point O to point A. So that's the notation. Even if you have displacement vector, let's say that you have vector B, and this vector is to vector C. And this is directed this way. So this we call the positional vector BC. Because initial point is B, and final point is what is C. So the magnitude we have that notations like that. So suppose that this is y-axis, and this is x-axis. So that's how we find magnitude of a vector. Sometimes you might even deal some of the directions of the vector or the angle made between the vector and the x-axis. That's not a great deal. Sometimes that. But let me just introduce it to you. You have, let's say, angle theta. So this is y components, this is x components, or this is I component, this is j component. So the angle theta, the directions, mean that direction for the two plane, direction of a vector, and this we measure by angle. This will be equal to the tan inverse of y component over x component. So also this is a very important point. In case that you'll be asked to find the direction of a vector, that's the general formula we are using to find it. Okay, and then we have some few terminologies which are just simple terminologies, and this the same terminology we have a terminology we call it eco vector. Say eco vector. Say ecovectors. So ecovectors, what are the ecovectors? So we say that are the vectors which have the same magnitude, and what and direction. So these are the two or three vectors which have the same magnitude and direction. So for instance, if maybe you want to sketch them, you can find that, for example, can have vector OA or vector A which is 2, 4, and also vector B which is 2, 4. So they have same magnitude. So if you find the magnitude of vector A and magnitude, so you find that the magnitude of vector OA will be equal to the magnitude of vector OB. But again, we have direction. So suppose that these are parallel vectors. So these are the two vectors which have the same magnitude. So suppose that these are the two vectors which in this way, suppose that this is 20 centimeter, and again so you have another vector here which is 20 centimeter again. Right, you have those two vectors. This is supposed that point A, which you call this is the final point. So this is supposed point B, point C, so we call it vector BC. Okay, and also this one is the same direction. This is vector D to vector E. So this is next, we call it DE, vector BE, like that ones. This in vector we call it tail, or tail points, or initial point, and also this we call it head. or equal to final point. So for this case, we say that cross have the same directions and same magnitude, then we say that these two vectors are equivectors. It's difficult to show the equivectors by using only the magnitude, so without using the plane, that means without drawing them, because also we can have the equal magnitude, we can have two vectors which have the equal magnitude but opposite direction, so those we call them opposite vectors. So then we have the first terminology. We have opposite. We enjoy the beauty of engineering mathematics. Opposite vectors. Please let me know in the comment section. Please also let me know that you enjoyed this material, from which institution, from which college, from which region, from which country, from which continent. So opposite vectors. So what are the opposite vectors? Okay? Opposite vectors, they might have the same magnitude but different order. The same magnitude but different, but opposite, but they have opposite direction, or they have different direction. So we say that these are the vectors, which have the same magnitude but opposite, was same magnitude and opposite what? In the opposite direction. So those two vectors, we call them opposite vectors. Call them opposite vectors because they have the same magnitude but different direction. This is still fundamental concepts of vector. A very interesting topic. Okay, so we say that these are the two vectors which have the same magnitude, so we can present example in a plane. You can have, let's say, a vector okay, so suppose that you have a vector, certain vector which has a magnitude of 20, and also you have another vector which have the same magnitude of 20 centimeter, right? 20 centimeter. So what happened there? So you say that's fine. So this is, suppose, vector A, or point A, this is point B. So directions of these vectors from this. So I say it is vector AB. Suppose that this is point C, tail of the vector. Now this is the head of the vector, and this is D, but the directions is opposite. So this vector we call T vector DC. So you say that vector AB is opposite. So this is opposite to what? To vector DC. That is. Again, another terminology, which is the fifth terminology, called the parallel vectors. Say parallel vector. So the fifth terminology, I want to teach you about parallel vectors. Very important concept in this subject. Parallel vectors, parallel vectors, parallel vectors, parallel vectors. Okay? So what are the parallel vectors, right? So I say that parallel vectors, these are the two vectors whereby one vector is a scalar multiplication of the other one. Parallel vectors are the two vectors in which one vector is a scalar multiplication. The scalar multiplication of the second vector. Scalar multiplication of the second vector. So So the scalar multiplication of the second vector. So for instance, if you say that vector A is parallel to vector B, so if vector A is parallel to vector B, so then we say that we write this in vector, that vector A is the scalar multiplications of vector B. Or we can say that vector B is the scalar multiplications of vector A. So whereby A and B are the vectors, whereby this one is, we call it the scalar multiplication. Scalar multiplication. So this we call it scalar multiplication. So that's the meaning of 40. That's the meanings of parallel vector. But you can have also parallel opposite vectors. Parallel opposite vectors are the vectors that are the vectors. So parallel vector opposite vectors are the vectors that are parallel, means that one vector is a scalar multiplication of the other, are parallel and opposite. So how do we notate in mathematics? For example, vector A, if it is parallel in the opposite to vector B, we have a negative sign to show it. Or if vector B is parallel to vector A, we have the negative sign to show it. So that's how. So these expressions is very important in the concepts that I will be teaching you in this module of trigonometric and vector, or in the topic of vector. So they look like fundamental and simple concepts, but they are very important for mastering the concept or the advanced concepts. The advanced concepts in this perspective or in this subject. Right? So we still have some few terminologies in order to start learning about, in order to cover the concept of 40, so in order to cover the concepts of terminologies, so then I can teach you laws of vectors. So the 6C terminology, we call it the unity vector. So say with me unity vector. Say unity vector. Say unity vector. Unity vector. So what is unity vector? Right? At the question. Very important vector. You will learn the concept of unity vector even if you pursue your undergraduate studies, your postgraduate studies, you will find these concepts of unity vector. I do remember that I found it there. So what is unity vector? Right? In simple ways. So a unity vector, we say that is a vector, is the any vector, is any vector. Right? Is any vector whose magnitude, we find it in physics, we find it in chemistry, we find it in mathematics, whose magnitude we find it in engineering, in science, whose magnitude is 1. That is. So for instance, that suppose you'll be given a certain vector, let's say that we have, suppose we have vector A. So the way that we notate, first of all, the notation of what of unity vector, this in maths, we have this symbol. that is unity vector. So the small kept like that present the unity vector. So for example, if you want to find the unity vector of vector A, so this one will be vector A divided by magnitude of vector A. Right? So suppose that we notate the unity vector by U. So the unity vector of U will be the vector U over magnitude of vector U. So let's say that this is the general formula for finding unity vector whenever you are asked to find whether the vector is two-dimensional or three-dimensional. You can find the concepts of unity vector. You can find the unity vector of a vector. We'll see some few examples soon. The last terminology, okay, not the last because that is the last, but according to this lecture, I would like to teach you about displacement vector. Displacement vector. Say displacement vector. Displacement actually means about the distance, physics, and that is the distance which are particular to direction. So for this case, you say displacements of one point. So what is displacement vector? So simply say displacement vector, this is the distance, or is the vector whose initial point, very important vector, initial point is not origin. In coordinate geometry, sometimes we call it translated conics, maybe translated parabola or translated hyperbola. Because in third year or in NT level 6, you learn about conics. So you have translated the parabola, translated the ellipse, translated the hyperbola. So we find that the initial point or the center of that conic sections is no longer at origin. Okay? So you say that the vector whose initial point or the tail is not starting from what, or is not what, is not origin. So these displacement vectors, we use the notation of, so the notation, the common notation for these displacement vectors is, let's say vector BC, let's say vector AC. We might be given 2 points, right? So when we given 2 points, and then we ask to find displacement vector. For instance, we'll be given vector B, which is x1, comma, y1. And also we'll be given the point C, which is x2, y2. So the positional vector, the displacement vector BC, for instance, for this case, will take the components of this, the final point, this the initial point. So initial point of vector, final point. So it'll take the x component of the final point x2 minus what x1, and then we say comma, then we take the y components of the C, it means of this, of the second point minus what, y1. So then we can have, this is a square brackets like this, right? So that is displacement vector. For instance, you'll be given that vector PQ, which is x1, let's say x1, comma, y1, comma, z1. Okay? And then you have Q. So Q, it is x2, comma, y2, comma, z2. Right? So for that case, you say that vector PQ, for this case, will be, this is the initial point, this is the final point. Okay, so you say that this is x2 minus x1, comma, y2 minus y1, then comma, z2 minus z1. Right? So if we interchange the positions of these letters that you have PQ, then this is the new displacement vector. So for this case, this Q is the initial point, P is the final point. So for this case, the displacement vector will be from the x1 minus x2, comma, y1 minus y2, comma, z2 minus z1. Now Z1 minus Z2. So also this is what displacement vector. Right? Interesting. So let me teach you the second example, the second simplest example, and then I'll leave the homework for you, and it will be the end of lecture 2. Ends of lecture 2. And this example says that find the displacement vectors for this. So do one, then we'll do the next one, right? I know that you are serious on solving problems. So let me clean all of these blackboard for the first phase and the second phase. Most we are still writing the second phase. Then we give you a simple example. This is example 2. So example 2, we said that the question stated find displacement vector. Find displacement vector. So find displacement vector. Roman 1, displacement vector AB. Roman 2, displacement vector DA. Roman 3. Okay, that is of 40 of this positional vector of point A, which is 3, negative 2, 3. And also you have point B, which is what? 6, negative 1, negative 4. So I'll do for 41, and this one will be your homework 2 or homework 1. Solution. The question asks us to find displacement vector. Roman 1 vector AB. So this is displacement vectors. So you take the coordinates of 40, take the coordinates of B minus coordinates of A. That is. So for that case, we say that we'll take 6 minus 3 is equal to 3. So let me write 6 minus 3, and then we'll take negative 1 minus negative 2, so it will be plus 2. And then we have what? 3 minus negative 4. So vector AB is equal to 6 minus 3 is 3. Then negative 1 plus 2 is 1. Then 3 plus 4 is 7. So that's the answer of Roman 1. Simple. Very simple. So I know that you'll be victorious. So again we have example 3. Question say find the magnitude. Find the magnitude. Find the magnitude and displacement. And displacement of vectors. Of vectors AC, and the CA, and CA, AC and CA. You reverse it. Given that given position of vector A, this is equal to negative 2, negative 3, 1, and C is -4, 1, -2. So I have told you about positional vector. I'll be just teaching you how you can find magnitude, but we cannot find magnitude until we get the displacement or displacement vector. So you have to formulate displacement vector first, and then we find the magnitude. So solution. So this will be your homework. This one, CA. So CA will be your homework. AC or anyway. So now let me interchange it, because you say maybe many previous examples. So please take this as your homework. So I'll do this one. So solution. To formulate vector CA, we say that we want to form vector CA. We take coordinates of point A, which is -2 for x component. We subtract with components of 40 of vector C, positional vector OC. So this is -4, so if you subtract, you get +4, and then you take -3 as y components. We subtract with 30 with +1, and then we take +1 minus, and then we add 2, just like this one. So you have CA, this is equal to what? -2 plus 4, this is 2, -4, 3. That is the answer for what? Displacement vector. So you say displacement vector CA, this one is equal to, you can even express in IJK component, but let us present the way it is. Maybe it can confuse you like that. So this is the response for the first part of this question. Then we have what? To find magnitude of vector CA. So the magnitude of vector CA, it is dimensional. The formula saying that we have to take x components with square, y components with square, z components with square. So we say that magnitude of vector CA will be the square root. What the components of C, it is 2 square, the x component, plus the y component is -4 square, which will be equivalent to 4 square. The next component is 3 square. So the magnitude of vector CA, for this case, is the square root of what? Of 4. So square root of 4, then this is 16, and this is 9. So it is 29. So simply you can say that the magnitude of vector CA is equal to the square root of 40, 29. That's the response, right? So you can try for AC. Again, we have the last example, which is example 4. Example 4. After this example 4, we end lecture 2 and join me in lecture 4, in lecture 3, 4, 5, etc., etc., etc. To enjoy the beauty of vector. Find the magnitude. Find the magnitude and the unity vector. Find the magnitude of unity vector of a vector that is 2i minus 3j plus k. Can have the wavelengths. So the question asks us to find the magnitude. So let us end with power to find the magnitude